All right, so we are talking about two-way tables here, 12.3. Okay, two-way table, we saw it in the warm-up, we saw it in the homework from last night in 12.2. But here's another example of a two-way table. Two-way table displays data collected from one source belonging to two different categories. So you're asking the same people, the same group of people, two different questions, and you're organizing their answers into four separate or more separate categories. Right, so if we look at this and we see we're talking about attending a school concert. Okay. Somebody raise your hand, tell me, what does that 25 represent in this problem? What does that 25 represent? Well, how many freshmen are attending? What about the 32? 32. Luke? Sophomores that are not attending, right? So we just kind of combine these two, and that tells me that specific number. Okay. Those numbers on the inside of our table are called joint frequencies. Okay, joint meaning we're joining two things together. We're joining freshmen and attending to get that 25. That is a joint frequency. Okay, we see that here. Each entry in the table is called that joint frequency. And then if we are going to add up and get the totals like we did in the warm-up, those are going to be called the marginal frequencies. Remember, margins are on the sides of your paper, right? You get your margins. So marginal frequencies are going to be the numbers on the outside. Okay, your numbers on the outside that are just going to be the totals. You're either adding straight across, you're adding straight down. You're getting those marginal frequencies by doing it. Okay, so you got to know the difference between joint and marginal. Joint on the inside, marginal around the outside. So that's our basics on two-way tables, our vocab part there. We're going to have you create one. It's going to be based on the same idea that we looked on above with the attending, not attending, only now they're asking juniors and seniors. Okay, I want you to create a two-way table, get your joint frequencies and the marginal frequencies. So I want you to do that full two-way table here with the marginal frequencies, and then we'll talk about it. we look at our 2A table. Numbers in blue, of course, the ones that give us, you got to be able to put those where they need to go, right? So they say 106 juniors, 114 seniors respond. That's going to be the total juniors and seniors. Okay, the total, because we don't know, it doesn't say 106 juniors are attending or whatever. It just says they respond. So that's the total. Of those, 42 are planning, attending, 77 attending. And then we can add straight down. We can do some subtraction going across, right? Use our logic to fill that in to get those numbers. Okay. Now, part of what they're going to ask you are what are these marginal frequencies representing? All right, so I want you to tell the person next to you what those three marginal frequencies represent.
And then the one below the one that's the total number of people surveyed.
All right, raise your hand. Tell me what does this 119 represent here? Here. Total people attended. There you go. How about the 220? What's that 220 then? Here. Yeah, total number of people surveyed. That is the grand total. That bottom right-hand corner is always the grand total of all of your joint frequencies added together. And it should, you know, if you add these marginal frequencies straight down and these straight across, they both need to give you that same number. If they don't give you that same number, then you did something wrong somewhere. Okay, your calculations are off. So this should give you 220. This should give you 220. There you go. What about that 114? That 114 here. Hold. There you go. Remember seniors that respond. Good. Okay, questions on our 2A table? All right, so that's our basic 2A table, but then we're going to go from there and talk about what's called a relative frequency. We've got a couple different relative frequencies here. There's one more that I'm hiding from you right now because I don't want to confuse you yet. We're looking at relative frequencies. The joint relative frequency, the marginal relative frequency. Basically, all we're doing is we are dividing each number in our chart here, in our table, by the total. We're taking each one of these numbers, we're dividing by that bottom right-hand corner, that 220 in this case. It's going to be a decimal. Okay, so our joint relative frequency, our marginal relative frequency, are going to be a decimal. Typically, they're going to have you write it in 3 or 4 places, probably 3. So what I want you to do is I want you to go through each one of these. I want you to divide each one by 220, and I want you to get a decimal rounded to the nearest 3 decimal places. Okay, go ahead and you can either create a new chart, or if you've got room, I'm just going to write it inside the same things. Okay, but that's what we're going to do. So round it to the nearest 3 decimal places for each one. Okay, so we see our numbers up there. We've got our joint relative frequencies, our marginal relative frequencies, rounded to 3 decimal places. Now, what should happen, right? It should just be like the numbers, where you can add straight down and get that value. So you can do your joint relative frequencies. You can add those two together to get that margin. It should work out that way. Now, rounding wise, it might be off. It might be off by 0.001 sometimes. And that's okay, because that's rounding, right? So if that happens on the quiz, I would accept either one. Whether you added straight down or you actually typed it into the calculator, I would give you both of them, because they're both valid ways of finding that number. Okay, and again, we should be able to add straight down and get 1. Add straight across and get 1, because that is the total. That is 100%. Now, we see these as decimals. How else could we think of them? Percents, right? We can think of these as percents, and that's how we would kind of use these relative frequencies. Because we can say, all right, 29.1% of everybody that responded were juniors that are not attending, right? 45.9% of everybody surveyed is not attending. We can use those numbers, these numbers, and sometimes those mean a little bit more than just 106 people are juniors. But what percent is that? That's 48.2% of the people that we surveyed. So we use those as percentages as well as those decimals. Okay, questions on that? Okay, the other relative frequency that we have is called a conditional relative frequency. We're adding a condition onto it. So we're not going to be dividing by the total. We're not dividing by the grand total this time. We are dividing by either the row total or the column total. And it is going to be important that you know the difference between a row and a column. Which way does a row go? Side to side. And a column up and down. Okay. I always remember because of the columns in a building, right? Columns of a building go up and down. That means the rows have to be side to side. Okay. So they might ask you to find the conditional relative frequency based on the row totals. So that would mean we're not dividing by 220, we're going to divide by the row total. So we would take 42 divided by 106 to get that conditional relative frequency. 64 divided by 106 to get the conditional relative frequency. Okay, so you got to pay attention to whether they're asking for the row or the column there, because you're going to be dividing by a different number based off of that terminology, that wording. Okay, so we just got to be aware of that conditional relative frequency. We're dividing either by the column total or the row total. All right, and this is how we're going to kind of use that conditional. And we used the conditional idea in the homework with that hurricane question. This is along the same lines. Now this is showing us the relative frequencies. Okay, those decimals. It's not giving us a hard number. It's giving us the percent here. We can do the same thing. Whether you're dividing by the actual number or you're dividing by the percent, it's going to work the same. Okay, so we've got two questions here, and we got to pay attention to the wording. Okay, because that's going to change how we're dividing and what we're dividing by. A says, what's the probability that a randomly selected customer who is located in Glendale will recommend the provider? So we want to know the customer who is located in Glendale. So we are only looking at Glendale for part A. And we want to know what's the probability that of these total number of people, they will recommend the provider. So we would have to add these together to get that total. And then to find that probability, we're just dividing. 0.29 divided by 0.34, and we're going to get that probability. Okay, that's our conditional relative frequency there. What is 0.29 divided by 0.34? Yeah.
2.85.
Okay, so we'd be looking at 85.3% of people in Glendale would recommend it for that. Okay, and then B, what's the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So it's telling us they will not recommend the provider. So now we're looking at the no row. And we want to know what percent of those people that said no are in Long Beach. So we got to add those up. We're looking at 0.12. We want to know in Long Beach. So 0.04 divided by 0.12. We're looking at 33%. So it's just a matter of finding that wording. Okay, that's going to be the tricky part. Is a lot of us are going to try to do the wrong thing because we look at the wording incorrectly. And we don't concentrate just on the row or the column. We try to do it out of the total. And that's not what they're asking. Any questions on that, on our conditional? I have one more problem for you here. Let you guys work through this together. See here, we're talking about a jogger. Wants to burn a certain number of calories during his workout. We want to know which route is going to be the best for him to use. Which one would make the most sense for him to use based on the data provided. Okay, talk to somebody about it. How can we figure that out? We're looking for which route and why. Which route should he use and why? Okay, what do we think? Which one do you think we should use and why? Haley?
I don't know if this is how you're supposed to do it, but I got route B because I did 11 minus 4, and then I did 12 minus 6 for C, and then 11 minus 6 for A, and the greatest number I got was B.
Okay, so that's one way to look at it. I think it worked this time. It won't always work that way. Okay, so it is route B, but why? How else do we get there?
You take the for route B, you take the amount of times he does reach his goal, and then the amount of times he doesn't reach his goal. You add them together and get that marginal frequency, and then you divide 11 by 15, you get like 73 point something.
Yeah, so if we do that for each one of these, that's going to tell us what percent of the time did he reach his goal on each route. So we're using that conditional by dividing by the total. So this is 11 and 6. This would be out of 17. This would be out of 18. So even though he reached his goal more times with route C, it took him 3 more times to get there. So if you divide 12 divided by 18, that's going to give you 67%, whereas this one gave you that 73%. We know it's going to be more likely that he's going to reach his goal on route B. Good. Any questions about it? No? Okay. We're good. Go ahead.